Hello everyone. Now I'm going to explain the practice number 12 for digital design circuits for this second partial. Now we're going to implement RAM memory. We're going to implement 4 bits address and data as length or as width of bits. Previously we did implement, yeah, the file register. So it's going to be some similar, only when we're going to implement a bus of data and address. As we are going to use the array to make this possible. So we're going to have two control signals. That's going to be the chip enable and write enable. This is going to control if we want to read or we're going to write on the RAM memory. So if chip enable is 0, we're going to cancel all of the buffers. So as output, we're going to have nothing. If we have only a chip enable on and write enable on 0, we're going to read the location from the memory that we select. And if both are in 1, we can write on the memory location that we have selected. So this is the block diagram. We have the address. We're going to implement a 4-bit address memory, and with 4 width with 4 bits, and we're going to have these two control signals. So this is the synchronous clock. I think that is the name in English. For the each one of the states of the address, data, chip enable, and write and read. So this is the block of the operation. We have a cell enable and write enable. Well, this is going to be the chip enable. If both are enabled, well, we're going to have an output. And if we only have the chip enable, we can only read. And if both are enabled, we can write here. The entire block diagram that we're going to implement is this. We're going to have a total of 16 spaces or registers that we can access with 4 bits address. Also, we're going to have a width of 4 bits of data, so we can watch in each one of the registers of the 16 register. We can visualize data of our information of 4 bits. So this in VHDL looks like this. Let me zoom this a little bit. Okay. In our entity, we're going to implement both control signals, chip enable and read and write. We're going to have the vector of 4 bits for the address. We're going to have 4 bits to introduce the data, the bits, the information, and also 4 bits to visualize the information of the each one of the registers on the address. For our architecture, we're going to have both signal controls. We're going to have cells of memory of 4 bits, and we're going to have an array of a total of 16 blocks. So also the control signals going to be a vector of 2 bits. This for the multiplexer that I'm going to explain right here. If control it's 1 0, so it's chip enable on and write and read in 0, we're going to read. So the position that we introduce in address, and we need to remember that is this one. This is the vector of 4 bits. we're going to access to the array memory, and we're going to display this on the output. And when it's chip enable on and write and read on, we're going to write on the memory. So in our input, we're going to save this information on the position of the address that we select. It's going to save on the array of the memory. If it's another combination, well, we're going to have a high impedance output. And this is all for the VHDL code. For the VHT or test bench, I have make these 3 examples. We write on the address 0 a 5. Now we save it to visualize this on the output. Now we write again 1 on 1 on the address number 1, that is the next address, and we're going to write 1010. We save this. Now we write again on the address number 8. We're going to write a 7. So I have already simulated this. This is the information. So for the output, we have a 5, 1010, and a 7 as the output. This is the information that we saved. And the RTL viewer looks like this. This is the block of the memory, 4 by 4. Sorry. Zoom out. I think this fit window, right? Yes. Also, we have each multiplexer for each one of the latches. This is for save information to output as final as the buffer that we have 4 bits. So this is all of the implementation of VHDL and simulation. Let me share with you how it works on the FPGA. We need to remember that this is a FPGA Altera Max 10. And is this one. I had already programmed this. So the first 4 dip switch, let me zoom in this. Yeah, the first 4 dip switch is for the address directions. The next 4 dip switch is for the data that we're going to introduce or when we're going to save. And the final 2 dip switch is the control. This is the chip enable, and next one is the write and read. These 4 LEDs is for visualize the output of the address. For example, right now I have the read only. So in direction 0 I have a 3. In direction, I think, yeah, in direction 2 I have a 2. And direction 8 I have a 1100. If I want to, for example, read in this direction, I don't know, an 8, a 9, I put this control on, and now I have already saved this information. So this is how it works. Thank you very much for paying attention.